All right, y'all, welcome to Math 0106. This is lesson 9. We're going to do a bunch of little things here today. We're going to start off with number 1, which is asking to write the word name for the number in the sentence. And so what we want to do here, let's see, 3.7853. 3.7853. And so the first thing I want to stress is what each of these digits represent. So the 3 here is the ones place or the unit place, okay? And then after the decimal, we have what's called the 10th place. And you want to emphasize the TH. It's not 10, because 10 would be if there was a number in front. This would be the tens place. Okay. Then the 8 would be the hundredths place, and just notice if we had another digit here, that we could say this is the hundred place, and then we have the thousandth, the 10,000th, etc., place. So when we're talking about these numbers, we need to make sure that we realize that when we have the TH, we're talking to the right of the decimal place. And also we want to emphasize that there is no such thing as the 1th place. Next question is how do we say this? And what we say here is, just to show you exactly what it says, we say 3, and, for the decimal, and 7,853 10,000ths. So 7,000, right? 853 10,000ths. So there we have it. Let's look at the next one. So the next one is going to be the sales tax rate of 8.25. So we have 8.25. So the way we say that is 8 and 25 hundredths. Now, what I would like to point out here, and in both of these, is here we see hundredths, because this is the 100th place. If we look back in the past one, we see 10,000th, because this is the 10,000th place. So what we essentially do is we say, if you look here, what the pattern essentially is that we're saying the back number. So 7,853, right? We're just saying this entire number. And then we say its place, so where it stops. So this is the 10,000th place. And again, that is deriving from this list here that we've created. So you can see on the next one, 8 and 25 hundredth, because it stops at the 100th place. Okay, cool. Let's move on. So the next bit that we want to talk about is how do we convert decimals to fractions? So in this instance, all you have to do is count the number of decimal places that you'd move over. So you can see you jumped 1 digit, 2 digits, 3 digits, and that's how many zeros you're going to put at the bottom. And that's it. Now the question says, the directions say do not simplify, so I don't have to go do anything beyond that. And so number 4, it looks scary, but you just write the number down without the decimal. And we can see we've jumped 3 spots, so we jump 3 spots. And I encourage y'all to type this into a calculator and see what you get. And you would see that you would actually, if you typed this number in here, you would get this as your fraction. Okay, let's do the next one. So I'm going to write the number. I'm going to put 45, and we have 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5. That's it. And number 6, I'm going to write the number without the decimal. You can see we jumped 3 spots. So we jumped 1, 2, 3 spots. And that's it. Now, in number 7, we're doing the same thing, only it's in, well, hold on, actually, let me read this. Convert the decimal to mixed numbers. So here, we do essentially the same thing, except we jumped 1 spot. So we'd write 7, and then because jumped 1 spot, it'd be 10. So this is 43 and 7/10. And number 8, so essentially I'm doing the same thing with the back part. and then we just rewrite the digit in front. And that's it. Okay, this is what I was thinking about earlier. So how do we convert fractions to decimals? So this is essentially what we've been doing, but in reverse. So we're going to write the number 3. And if you have 2 decimal places, that means you would jump 2 spots. So we'd be left with 0.03. So let's do another example. Let's do number 10. We'd write 103, write the decimal. We have 2 spots. If we jump 2 spots, we'd be at 1.03. Let's do the next one. We write 137. Notice we have 1, 2, 3, 4, 5. So this means I'm going to jump 3 and 2 more. So I'd add 2 zeros, and then I'd put a decimal. So let me rewrite it so it looks nice. And the last one, we take 123,067 with 1, 2, 3, 4 decimals. So we jump 1, 2, 3, 4 slots. So this would be 12.3067. And there you have it. Okay, and now let's look at number 13. So in 13, they're asking which is greater. And my advice here is always relate things back to the real world. So you know this, 67.89 versus 67.98. Which one would you rather, which one's cheaper? 67.89. So something that costs $67.89 is clearly cheaper. So the symbol we use is this, which means this value is greater than 67.8, or 67.89 is less than 67.98. So that is essentially all that is going on here. If you wanted a systematic way of approaching it, what we would do is we would start with the leftmost number, and they match, and then we do the next one, they'd match, and then we do the next one. When I say number, I mean digits. Digits are 0 through 9. And what we see here is that because this digit is greater than this digit, this number is greater than this number. Okay. So in the next one, we can incorporate the same strategy. So we can say we have 0.0342 versus 0.04. So again, we're just going to look and we see the zeros match up. Then we see 3 and we see 4 because 4 is greater than 3. This is greater. Another way of looking at this, if that's not making intuitive sense, is if you add zeros, this is like saying 3.42, this is literally 3.42%, we'll talk about that later, and this is 4%, right? So keep that in mind as well. Okay, let's move on. Okay, so we have some more examples here. We can clearly see that 9 is greater than 7, so this number will be bigger. And if we count the zeros, we have 1, 2, 3, 4, 5 zeros. Here we have 1, 2, 3, 4, 5. So here you can see you're at 0. Here we're at 1. So this number is greater. Okay. Now it's only a coincidence that the answer consistently is the number on the right, but that is not always the case. Now number 17. This question is very, very important to make sure you understand how to do this. So we talked about place values earlier. We said this is the 10th, this is the 100th. So we're looking at 8 here as the 100th place. How do you round? What we do is to round, you look at the number to the right. And we look at the digit rather, and it's 4. If the digit is 4 or less, you leave the number as is. Number as is. If it's 5 or more, then you bump it up 1. Okay. 4 or less, leave it the number as is. 5 or more, you bump it up. And when I say number, right, what I really should be saying here is digit, right? We're talking about it would be bump the digit up 1, right? Okay, so let's look at this here. Okay, so we're looking here and we see a 4 here. So what that means is we said 4 or less, leave it alone. So this is just simply 72.38. Okay, so this says, next one says round to the 1,000th. So again, we said this is the 10th, 100th, thousandths. So the initial 4 is 1,000. So it's very similar to the last one. We can write this as 0.034. Again, 4 or less, you leave it alone. Okay, let's look at the next one, 10th. Now, this is the one you want to make sure that you are aware that we start with the 10th place. A lot of people think sometimes that it's the 1th for whatever reason, but 9 is the 10th. So we would bump it up, but if we bump up 9, we're back to 0, which means that this becomes 20. So technically, it should be 20.0. I don't think that that's going to matter for your test, but technically speaking, I want to put the 0.0 there to emphasize that I am taking into account the 10th place. Okay, and then with number 20, we said that 1, so you don't have a TH or anything like that. So we're looking at this 4 here. So we look at the digit to the right. It's a 7, which means I bump it up. So it's 25. And there you have it. So it's a little shorter than the previous videos, but this is just a little bit on decimals and rounding and understanding how to read mathematics. So hopefully this makes sense and this isn't too bad, but let me know, send me an email, post something in the comments, and I'll respond to any concerns. All right, I'll see you guys in the next math video.